Welcome to Senior Fellows. Let's get our books ready. Our topic for today is said under relative mathematics. So let's look at the importance of said or relevance of said. Without said, equation cannot be written. Yes, without said, equation cannot be written. So one of the relevance of said is the Golden ratio. This ratio is aesthetical beauty in architecture, and with this, its value said is inside. So we have root 5 here, and this is how the golden ratio look like. So you can go and search on it. Another relevance of said is the shape of the parabolic curve. So this is used in car headlights and even searchlights. So we are talking about the U shape, that's the quadratic curve. Good. The solution of this equation sometimes are irrational and it requires a set. The next one is for creating 3D video game. Without set, equation cannot be written to generate 3D image or videos. So the video game that we are playing, all this that is the coding behind it said is that's what we need. So without the set, you cannot generate all these images. Okay. Real numbers. We did real numbers at the basic level. This is not the first time doing the real numbers. And we said we have two types of real numbers. That is rational number and irrational number. Here, our main focus will be on the irrational number. And we said the irrational number is a number that is non-terminating, non-recurring. And the real numbers, they can terminate, they can what? Recurs. But irrational number, they are non-terminating and non-recurring. So the example here, we have the pi. And you remember, we said the pi is 22 out of 7 or 3.142. That is not the pi. It goes beyond that. It does not terminate, does not recur. So the numbers goes beyond that. So 3.142.143, it goes. And we have the Euler constant. That number, the E, is on your calculator. You can see. So, and we have the set with 2. So when you say with 2, in our calculator, it's up to 2 decimal place. That is not with 2. It goes beyond that. It does not terminate. We have decided to put it on that 9 decimal place on your calculator. It goes beyond that. So these are irrational numbers. So we have the pi, the e, and the set here. Therefore, we can say that not all irrational numbers are said. However, all said are irrational numbers. Not all irrational numbers are said. However, all said are irrational because irrational numbers we have the pi, the e, and the said. So not all irrational numbers are said. However, all said are irrational numbers. So take note of that. So our objective by the end of the lesson, the student will be able to define said, solve arithmetic operation on said, rationalize said, conjugate said, then determine the positive root of a binomial said or solving said equation. Sets. Sets are irrational roots of positive rational numbers. Irrational root of positive rational number. So this is said. The n is the order or index, and our a is the base or the radicand. Then the sign is the radical. So this is called the nth root of A. What about this? The 3 here is the order, and the 5 is the base. Then the sign is the radical. Therefore, this is called the third root of 5. Good. Qualification of surd. What qualify a surd? So 1, the radicand, that's the base, must be a positive rational number. Yes, the base must always be a positive rational number. 2, there must be a radical operating on the base. That's the sign, the radical. Yes. The results must produce a value that is non-terminating or non-recurring. That is surd. Good. So example, is root 25 a surd? Solution. So root 25, when we break it down or when we use the calculator, is positive 5 or negative 5. So is positive or negative 5 a surd? No, because positive or negative 5 is rational number. It's not irrational number. And this one is even terminate. So it's not a surd. Good. Perfect square. We already know perfect square. We have been using it. What are perfect square? It's when two identical are multiplied together to form a number. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. So 3 to the power 2 is 9, 2 to the power 2 is 4. So these are the chart for perfect square. 1 square, 2 square. So 1, 4, 9, 16, 25. These are the perfect square. And the roots of a perfect square give us a number. So that's why we have square root of a perfect square. So square root of a perfect square of 4 is 2. Yes, because the square root is half. And we know that 2 to the power 2 is 4. So the 2 will cancel the half. Let's move on. How to reduce surd to the basic form. This is to reduce the root of prime number, that's surd. So let's simplify this. We want to reduce root 24. How? First of all, we will ask ourselves, what perfect square number times what number will give us 24? Yes. So 4 is a perfect square because 2 times 2 is 4, or 2 to the power 2 is 4. So 4 times 6 will give us 24. Then we multiply each of them. Root 4 times root 6. Then we know that root 4 is 2. Why? Because the square root is half. So 2 to the power 2, the powers will cancel. Then you will get 2. So the square root of 4 is 2. Then as for the 6, it's not a perfect square. So root 6 is irrational number, a surd. So therefore our answer is 2 root 6. Let's try another example. Root 32. Yes. So what perfect square times a number will give us 32? We have 16 times 2. Yes. 16 times 2 will give us the 32. And note that 16 is a perfect square because 4 times 4 is 16, or 4 to the power 2 is 16. So it's a perfect square. So let's multiply it separately. Then root of 16 is 4 because 4 to the power square is 16, and the 2 cancel the root, and note that the square root is half. So 4 times root 2. As for root 2, it's a set because you cannot find a perfect square for root 2. Therefore, our final answer is 4 root 2. "48. Let's try this. Yes, I'm waiting. Okay, good. So what perfect number? 4 times 12. Yes, 4 is a perfect number and 12 is not a perfect number. So root of 4 times 12. So still we can reduce the 12. So 4 times 3. Then root 4 times root 4 times root 3. You know that root 4 is a perfect square. So it's 2 times 2 times root 3. Then with multiplication, we'll talk about it. So 2 times 2 is 4. Our final answer is 4 root 3. Let's try this. Root 48. So 16 times 3, 16 times 3, root 16 times 3. So therefore, our final answer is 4 root 3. We are still on reduction of set to the basic form. So there's a smart way. We are going to use the calculator to do that. Then, so that you will not miss the method, you can use the calculator to do that. Simple. So let's simplify. Root 98. So on your calculator, punch root 98 and it will give you 7 root 2, right? That's the answer. But if you buy 7 root 2 for us, you only get the answer. You have to get the method too. So you will square the one outside, then you use to multiply the 2 all in root. Please. So you square the 7. Then you square the 7 is 49, right? Then 49 times 2. That's how we are going to do it when you are using a calculator. So therefore, 49 times root 2, have you seen? Then you take root of both sides. So root 49 times root 2. Then it will give us 7 root 2. That's the simplest way. Let's try another one. Root 128. So on your calculator, you will get 8 root 2. So for us to get our method back, you will square the 8. Then if you square the 8, it's what? 64. Meaning root of 64 times 2 will give us 128. Yes, 64 times 2. Then you had your method back. Then the root again, root 200. On your calculator, root 200, what do you get? 10 root 2, right? So I said what? Let's square the 10 and multiply it by what? The 2, or in roots. So 100 times 2. Then if you simplify further, we get 10 root 2. Now, what about this? Root 576. Yes, 576. What do you get? 24. Now, there's no root here, so this one is 24. So what should you do? Yes, good. Now, this shows that the root 576 is a perfect square. Yes, 576 is a perfect square, meaning 24 times 24 will give us 576. So sharp. You multiply 24 by 24, all in roots. That will give us 576. Then in multiplication of said, we will reach there. We know that 24 times 24 is all square. Yes, 24 times 24 is all square. This is how we write it in multiplication. We will explain further. Now, we know that the root is half, so the half will cancel the 2. So therefore, we will get our 24 back. Yes, so 576 is a perfect square. That's nice. This is how to reduce a set to the basic form. Subscribe to Senior Pelus, my YouTube channel, for more videos.